Okay, now we're in 7.4, which is on rectangles. So we're going to talk about our properties of rectangles here. A rectangle is a parallelogram, so that's important to know. All of the properties we've talked about with the parallelogram are still true for a rectangular, okay, with 4 right angles. So we have this extra big property here. From this definition, you know that a rectangle has the following properties. So all 4 angles are right angles, opposite sides are parallel, that's from a parallelogram. Opposite sides are congruent, that's from a parallelogram. Consecutive angles are supplementary, that is from a parallelogram. And diagonals bisect each other. So what you're recognizing there is that all of those properties are true. In addition, you also know, so you just learned that 4 right angles, okay, or you know that from your definition of rectangle. But in addition, the diagonals of a rectangle are congruent, okay? So if you were to draw in diagonal AC and diagonal BD, those are actually congruent to each other in a rectangle. So this is kind of that new property for rectangles. So if we solve through some of this stuff, J is framing a barn door with an X brace as shown, so you can kind of see that in there. They give you RT, so they have RT to the middle here to be 3 and 9/16, and then QR, so we go from Q to R all the way down the side here is 7 feet. And the measure of angle RTS, so RTS, this angle in here is 65 degrees. Find each measure. If a measure is not a whole number, write it as a decimal. So you don't have to worry about doing your fractions there. So if we have these angles QTR, they want QTR. So that one's going to be 180 minus the 65 that's in there. So 115, assuming I know my math here is good, just making sure I don't write any of them down wrong. And then our TQR, so TQR, that's this angle up here. So what I'm going to look at is this full triangle here, I believe. Actually, no, I'm not. I'm going to be looking at, let's go backwards, at this isosceles triangle here is what I'm going to look at. So in a rectangle, we know that the diagonals bisect each other and they're also congruent. So if this is congruent to this, so PT is congruent to TR, and then I know that QS is congruent to the whole thing. Well, when this one's split, it's also congruent. So we have a isosceles triangle here. So I got 115 for that vertex angle. So I would do 180 minus the 115, which is going to give me 65. And 65 is the other 2 angles that are congruent. So I'm just going to divide that by 2, and that's going to give me 32.5 degrees for that one. Measures wise, PS. So PS is a side opposite of QR, which was 7 feet. So that's going to be 7 feet. And SQ, which is the diagonal there. Let's see what we knew. We knew that part of the diagonal was 3 and 9/16. So we're just going to double that. So for this one, it's going to be 3 and 9/16 times 2, but it tells us to give it as a decimal. So we can just give 7.125 feet for that one. Okay, so lots of things coming up there, but lots of properties that we need to know. Okay, so we also have another rectangle here. That's what they tell us in this one. So we know it's a rectangle. We know lots of things. It says if mn is equal to 3x plus 1, so we have 3x plus 1 here, and jl is equal to 2x plus 9, so that whole thing is 2x plus 9, find mk. So what I know here are 2 things. I know that diagonals are congruent, so I know that jl is equal to mk, and they gave us jl to be 2x plus 9, and that's equal to mk. Now, I don't necessarily know mk, but I do know that the diagonal is bisected, and so therefore, if this is 3x plus 1, the other side's 3x plus 1 as well. So the mk can be 2 times 3x plus 1. So that's where I'm getting my equation from that I'm going to solve here. I'm going to distribute. That's going to give me 6x plus 2 equal to 2x plus 9. Subtract my 2x, I get 4x. Subtract my 2, I get 7. And divide by 4, I'm going to get 7/4, which is 1 and 1.75. Or sorry, that is going to be my x value of 1.75, and it asks us for mk, the whole thing. So it wants us to know what 6x plus 2 is equal to. So 6 times 1.75 plus 2 is what we're solving for in there, and that's going to give us 12.5. Okay, so that's one of them. Now, that said if. So what we have to remember with if is that means that's only true for that part there. So then when we go to solve the rest of this, that all goes away. Okay, that diagram doesn't have anything on it now, and we have to start over. So angle JNK is 5x plus 2. And then JNM is 3x minus 6. So those 2 angles add up to 360. So I'm going to add them together, which is 8x minus 4. Sorry, add up equal to 180. Oops, if I say the right number, equal to 180. add my 4, divide by my 8. So I'm going to get 184 divided by 8, which is going to give me 23. So x is going to come out to 23, and then I'm going to solve. So I'm going to put 23 in here. 5 times 23 plus 2 is going to give me 117. And I'm going to put, I believe in here, JNM, yep. I'm going to put 23 in here, and that's going to give me 63. Again, feel free to pause the video and go check or do it yourself, but that's what you're going to do with that. Okay, so proving that parallelograms are rectangles. So once you've got the properties down, then we have to talk about proving that we have a rectangle. So you've learned that if a parallelogram is a rectangle, the diagonals of the parallelogram are congruent. The converse is also true. So if the diagonals of a parallelogram are congruent, then the parallelograms are a rectangle. So you have to prove a few things. You have to know that you have a parallelogram. Sorry, get this. You have to know that you have a parallelogram, and you have to know that the diagonals are congruent. Okay, so those are the two things you have to know. And if that's the case, then you can say that you have a rectangle. Okay, so proving that, okay, so we have that this is a rectangle. Actually, this is not proving a rectangle here, but we have that this is a rectangle. And given a congruence there, we're proving another congruence, so that QT is congruent to RT. So we've got our givens. PQRS is a parallelogram. Definition of a rectangle allows us to say that we have a parallelogram. Opposite sides of a parallelogram are congruent here. So opposite sides congruent, what we have to deal with here, I believe, is going to be that we want to say that segment QP is congruent to segment RS. So we're going to go with that one. I will also tell you that you can skip step 2 here, and you would just instead here say opposite sides of a rectangle are congruent, because that is also true. Okay. Then they use the definition of a rectangle. So that's talking about the 90-degree angle. So we're going to say that angle P and angle S are right angles, because that's using that definition of a rectangle, a parallelogram with 4 right angles. And then they say angle S is congruent to angle P because all right angles are congruent there. So we've got that. And so we have these two pieces we do. Okay, and then the 90 degrees. So we have side angle side that we're able to prove the triangle's congruent. So triangle QPT is congruent to triangle RST. By side angle side. Now you could have potentially done this by leg, but they said that the angles were congruent, so that's where that one comes from there. And then CPCTC allows us to say that the two other pieces, so QT is congruent to RT by that corresponding parts of congruent triangles are congruent. Okay, so utilizing those properties of rectangles. A quadrilateral with vertices at these points here. Which of the following points would make this a rectangle? So I would just kind of do a quick sketch here. So A is going to be at 2, 6. B is going to be at, so we're at 2, 6. B is going to be at 3, 7, so just above it. And C is going to be at 6, 4, somewhere down here. And we want to make a rectangle out of that. So first thing I want to do is figure out if A or C is supposed to connect. So AB here is over 1, up 1. So this slope is 1. And so I want a -1 slope. So from B to C, the slope would be 7 minus 4 over 3 minus 6 would be 3 over -3, which is -1. So BC is the slope that's -1. So that makes my right angle there. And then I just essentially want to keep those slopes the same to make this a rectangle. So what I'm going to do is make the easiest one. The slope of 1 here, that's only 1 unit apart. I'm just going to go down 1 over 1 to get that other point that's going to be there. And so we're going to be at 5, 3, just below C. So we're just to the left and just below C, which is at 5, 3. And so that's going to be my point. Now you could go through order or go through process elimination, but that's kind of how I dealt with it. And I used my slopes to figure it out. You could also graph to figure it out. Okay. Not like a sketch to figure it out. You could graph. Okay. So that's where we are going to stop for today.